Everybody, I had promised Dr. Pamela that I was going to give you this little workshop on quantitative methods focusing on correlational and experimental research. Now, because of different reasons, I was not allowed to be there with you, so I will share with you this little presentation that I will give you some, highlights into these two different research methods. So in this lesson we'll talk about quantitative research, focusing in particular on correlational research and experimental research. Let's begin by reviewing the dimensions of research methodology, because this information is going to be important in the discussion of the experimental and the correlational methods. Now, first of all, in research we have approaches, and then we have methods, and finally we have data collection instruments. Obviously, the approaches refer to your philosophy or the principles that guide your research. So we need to start off by establishing what science is all about for us, how we see science, how we see the purposes of research, the objectives of research, the ways in which research should be done, and this is what your approach is going to be about. Once you have an approach, the next step is obviously to select a method, a way to inquire, and then obtain the information that you need to answer your research questions or test your hypothesis. And finally, the instruments refer to the simple data collection devices that you're going to use. So, some examples of research approaches will be action research, explorative research, positivism, post-positivism, and so on and so forth. In terms of methods, obviously we have some examples such as the experimental and the correlational methods that we're going to be focusing on in this presentation. And finally, some examples of data collection devices will be questionnaires, observation forms, checklists, and so on and so forth. Now let's look at the definition of quantitative research, because it's going to be important in the discussion of correlational and experimental research. So first of all, we can say that quantitative research is the one that produces results that can be used to describe or note numerical changes in measurable characteristics of a population of interest. That is, that when we do experimental research, we will be able to generalize to other similar situations or populations, and then provide explanations or predictions, and then explain obviously the causal relationships between different variables. Now obviously this method is based on positivism and post-positivism that have a root obviously also on determinism. This means that this kind of research is based on the scientific method. So people believe that in order to do research you should have like strong empirical and theoretical basis. Determinism in particular suggests that examining the relationships between and among different variables is central in testing hypotheses by means of surveys and experiments. From the previous information, we can now see the most important components of quantitative research. First of all, measurement. Every single piece of data that we have must be transformed into numerical form so that we can assess its magnitude. So measurement is at the core of quantitative research. Secondly, obviously, you must have empirical and or theoretical basis. So this means that you don't start your research with an open question. You start from the theory, from what other people have done, from what other people have found, and the only thing that you're going to do is test hypotheses to decide whether or not like these theories that you're establishing are valid or not. The fourth component is observable and measurable data. So that any kind of data that you collect must be concrete, observable, and measurable, so that you can study it in terms of different kinds of relationships and statistical analysis, which is the last part of quantitative research. So there are specific procedures that we're going to use to carry out the analysis, but everything is in the numbers. This means that the weight of a quantitative research lies in the amount and the quality of data that you're going to collect to test your hypothesis, and therefore confirm the theories or the principles that you have established from the beginning by means of appropriate, reliable, and valid measurement. Now we're going to look at two examples of quantitative design. Imagine that we have the following hypotheses. First of all, we think that playing violent video games is related or is associated with higher rates of play aggression in kids. So we think that two variables are related, and what we're going to do is we're going to test if this is really the case. A different hypothesis would be that playing violent video games causes aggressive behavior. So if you see here in this second hypothesis, we're talking about a cause and effect relationship between the variables. So this means that we believe that if children play violent video games, they will become aggressive. These are the two basic kinds of hypotheses that we're going to find in quantitative design. So in the first case, one variable is related or has a relationship with another variable, and in the second case, one variable causes another variable. And these are the two most important kinds of quantitative research. The first one is called correlational research, in which we're going to find if there's a linear relationship between two variables, and the second one is experimental research, in which we're going to see if one variable is responsible for causing another variable. And this is obviously what we call experimental research. Now let's summarize the characteristics of correlational research. First of all, what kind of information do we get? Obviously, in correlational research, we collect evidence to demonstrate the existence of a linear relationship between two variables. How do we do it? Obviously, by means of collecting quantitative data about those variables and then performing a statistic that is called a linear correlation. We do this by means of a software which is called SPSS, which is going to determine if the two variables are related or not. Now, what are the advantages of correlation research? The advantages are obviously that it's very practical and it's very straightforward. The only thing that we do is we see the variables that we want to correlate, we collect numerical data related to those variables, and then we run a correlation using the software called SPSS. The disadvantages are obviously that this software is very expensive, it's extremely expensive, and that it is important to select appropriate variables, because we cannot select just any kind of variables and test them. We need to see which variables are important, which variables could really be related, and whether or not they're going to give results that are going to be useful or not. We cannot just correlate everything that we want. And obviously, when we get the results, what we are getting is just confirmation that these two variables are related, that there's a relationship between the variables. However, we don't get information about the nature of this relationship. We don't know exactly how these variables are related, or we cannot explain it in a clear way. I mean, we can hypothesize, we can try to explain, but we don't get information about the nature of the relationship. We simply get a confirmation that the variables are related in terms of the statistical analysis. And some characteristics of correlation research is that it's cross-sectional. So this means that we don't need to invest a long time doing correlation research. We can simply collect the variables and then we run the correlation. It can be done relatively quickly. So it's a cross-sectional study. We can do it in one go. And obviously, it is quantitative in design. Now let's see what we really mean by correlational research. Obviously, we're trying to find evidence of the relationship, a linear relationship between two variables. So we're going to see a graphic example of the three most important things that we can find in correlation research. Now let's imagine that we're trying to find a relationship between two variables. The first variable is going to be attendance to class. The second variable is going to be the grades or the scores that students get in a given course. So we believe that these two variables are related. This means that the students who get the highest grades are the ones who have attended classes most often, which, I mean, it's just a silly example, but it's just to see how there could be a relationship between these two variables. So first of all, we're going to calculate the number of times that our students came to classes, and we're going to, the second data that we're going to collect are going to be their scores, their grades in the course. So something that we can find, or what we're trying to find, is evidence for a linear relationship. So this means that the more one of the variables, the higher one of the variable is, the higher the other variable is going to get too. So this means that as one variable increases, the other one is going to increase in a similar extent or magnitude. Let's look at this. For example, imagine that one student comes 2 times to classes and he gets like 2 or 3 of final grade, and then another student probably attends like 5 times and gets like a 6 in their final grade. So the idea is that the students who attended most often are going to be the ones who get the highest grades. And you can see here that when we graph the 2 points of the different variables, of the values of the different variables, we're going to see that there is a direct linear relationship between 2 variables. The more the attendance goes up, the higher the grades. And this is basically what we would find in an ideal world, because obviously it's going to be very difficult for you to find a perfect linear relationship. That doesn't exist at all. Okay, this is just like fantasy, but it's just an example of the first thing that you could find. And in this case, the correlation coefficient, which is represented by R, will be of 1.0. If you get 1.0 in a correlation, this means that the variables have a perfect linear relationship. Let's look at a second example. Now, something that could happen is also that, in fact, when you graph the results, the numerical data of the attendance and participation, that probably the people who attended the least will get the highest grade. For example, this first person attended like 3 times, but they got the highest score of 10. And then another person probably attended like 5 or 6 times and got like 9.5 or something, and so on. So the idea here is that maybe the people who attended the least obtain the highest grades, and this will indicate obviously an inverse linear relationship, an inverse perfect linear relationship between 2 variables. So this means that the less the students come to classes, the higher scores they get, which obviously will be crazy, because this will mean that the more they come to classes, the least they learn, right? And again, this, you're not going to find this in real life, but this is just an example of what could happen, in the second scenario, in which everything will be completely different. In this case, the correlation coefficient, which is represented here by R, will be of -1. So this means that there is a perfect inverse linear relationship between the 2 variables. Now let's look at what could happen in real life, and this is very frustrating. This is the most frustrating scenario for every researcher. So obviously, attendance to class is just one of many variables that affect achievement or learning or high grades that are represented by this. So in this case, probably what we're going to find is that maybe there will be different cases. For example, somebody attended all of the classes, but this person got 6, which is a really low grade. And maybe there could be another person who attended 25 times too, and then got like an 8. And so in general, we might find that regardless of how many times people came to classes, they got different grades. In other words, that when we try to graph the relationship, we see that in fact there is no relationship between the two variables. This means that it doesn't really matter if you come to classes. There are different factors probably that are causing a good or bad score in your final grades. This will mean then, in this kind of situation, will imply that there is no relationship between two variables, that the variables are unrelated, and in this case you will find that R, which is the correlation coefficient, is almost 0, it's very close to 0, which indicates that the variables are not related. This is very frustrating, but obviously this is something that you can find in your research. Sometimes we're excited because we think that we're going to find, relationships between different variables, and then as a matter of fact, in most cases we will find either that there is no relationship or the correlation is not significant. In other words, that it may be due to chance, that it's random. Now let's turn to the statistical significance of a correlation. First of all, the number that we use to calculate this relationship is called the Pearson product moment correlation coefficient, which is represented with with a small r. Now this number indicates the magnitude of the correlation between two variables. Okay, this is going to be calculated by the computer. The maximum values are 1, which indicates, as we said before, a perfect linear relationship, and the minimum value is -1, which will indicate a perfect inverse linear relationship between two variables. Now, the researchers are usually going to determine the cutoff points that they consider valid in deciding if the value of R is high enough to support the hypothesis. But obviously, the computer is going to give you an indication of the significance of the relationship. This means that we're going to find some symbols, for example a star, if the relationship is just significant to a certain extent, that there is a relationship, but it is not true, or it is not completely true that the correlation is significant. If you get 2 stars, this means that definitely there is a clear systematic relationship between two variables. And obviously the significance can be estimated. The computer does it, okay, so you don't need to worry about this, by squaring the value of R, which is the shared variance. Let's look at some examples. So this shared variance refers to the magnitude of the overlap between the two variables. So imagine that in one situation we have a value of 0, the correlation coefficients. When we square it, we get 0, because 0 multiplied by itself, it's 0 again. So this means that the two variables that we're trying to correlate are unrelated. They are separate variables, they have nothing in common. Get, for example, that the correlation coefficient is 0.6, and then therefore the square value of R is 0.36. In this case, this means that there is an extent of overlap between the two variables. This means that part of this thing that we call the shared variance is causing an overlap between the two variables. There is a relationship between them, but obviously this relationship is still small, it is not significant. The relationship between the two variables may be due to chance. And finally, in the cases where we find that the correlation coefficient is 0.85, for example, which gives us 0.72 when we square it, this will mean that the two variables that we're studying are in fact highly correlated. This means that there is a huge magnitude of overlap that causes, or that confirms that these two variables are related. The shared variance here is really high, and therefore we can say that there is a clear linear relationship between these two variables, and this will be significant. Now we're going to end by giving an example of correlation research. This is a thesis that I directed back in 2001, and it's called the evaluation of reading comprehension in French as a foreign language and mother tongue, a correlational study. It is in French. It was one of the first theses that I directed in French. So basically, my student was teaching at that moment in a public SEP high school, and then there was a pilot program in French. So they were teaching high school students French, but it was just reading comprehension. They thought it was going to be easy because, you know, French and Spanish are very related, so they're similar in writing, and they thought that it was going to be easy to teach them reading comprehension. However, the students were getting really low results in this pilot course. So obviously, they didn't think that the problem was the level or the difficulty of the exams, because the texts that we're using, they were, you know, appropriate to the level and obviously their age. So there was something else, and the hypothesis was obviously that they had low reading comprehension in Spanish. In other words, it was difficult for them to understand reading comprehension in Spanish, and therefore the results in French were similar. In other words, there was clearly a correlational hypothesis that L1 and L2 reading comprehension were related, and therefore that was the reason why the students got low results in French. So what did we do? We set out to test this hypothesis. This is the hypothesis: low reading skills in L2 are related to low reading skills in L1. So the students are bad readers in Spanish, and therefore they are also bad readers in French. So the first step was to design 2 reading comprehension exams. This is a long process because there was the test design, looking at the construct, piloting the test, validating the test, and so on and so forth. And so these 2 reading comprehension tests were designed to collect data on students' reading skills in both L1 Spanish and L2 French. Secondly, the tests were administered. Once they were finalized, when we found a good estimates in terms of validity and reliability, and then we analyzed the results. So we gave the test, we calculated the descriptive statistics, we run again the validity and reliability tests to calculate, you know, the scores that they got in L1 and L2 in the reading comprehension skill. Then obviously, once we had the scores, when we had all of the statistics, we run a correlation between the 2 sets of scores. So the scores were entered in SPSS and the correlation was run. And obviously, when we analyzed the data, we realized that there was a significant linear relationship between the 2 variables. So the students had low results in reading comprehension in French because they also got low reading comprehension skills in Spanish. So we found that there was a linear relationship between these 2 variables that we tested, and that was the results of the research. And it was very interesting to find that in fact it was not that the French was difficult for them, but actually that they needed to be trained in reading comprehension because they could not understand texts that were written in their own mother tongue, and that was like the main reason why they were failing in in French. And so this is the end of our first lesson on quantitative research that focused on correlation research. In the next one, we're going to be looking at the experimental method. Thanks a lot for your attention.